the element inserted the last will be the one to be deleted first. So that is the concept of last in, first out. Array is a group of elements of similar data type, and we know that all in arrays, all the elements are stored in a sequence that is in the index. The index starts from 0, 1, so on. Suppose this is the first position, and we know that top is the pointer where insertion and deletion takes place. Dear students, welcome to Computer Science Revision classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, let us start our discussion with the chapter Data Structure. Now, in this session, we are going to talk about the linear data structure. They are stacks and queue. Now, let us see introduction to stack. So, what is a stack? A stack is an ordered collection of elements or items where addition of new item and removal of existing item always takes place at the same end. This end is referred as the top. The end opposite to top is known as the base. So, first of all, what is a data structure? We have learned a definition in our previous session. So, it is a collection of elements in indefinite order. So, here stack is a data structure where the elements are arranged in definite order. So, in a stack, the property is that the addition of new item and removal of existing item means, suppose if you want to add one element into a stack, and if you want to delete one element from the stack, so in that case both the operation takes place at the same point. That point is called top. So this is the definition of stack. It follows the ordering principle of LIFO. That is, LIFO stands for last in, first out. So what is the meaning of last in, first out here? The new items are near the top while older items are near the base. And here we know that the top is the place where we are entering or we are inserting a new element at the top, and the base is opposite to it. So newer items are near to the top while older items are near the base. And a stack of books on a desk is an example of a stack. Means if we are keeping a books one over the other on a desk, it is an example of a stack. So what is the meaning of last in, first out principle? So here stack is a data structure which follows LIFO principle, last in, first out. The meaning is the element inserted the last will be the one to be deleted first. So that is the concept of last in, first out. The element inserted at the last as the last element is the one to be deleted first. That is the concept of LIFO, that is last in, first out. So this is the definition of a stack. Now, array representation of a stack. Stack can be represented using one-dimensional array. So we are using one-dimensional array to represent a stack data structure. So the items into stacks are stored in a sequential order from the first location of the memory block. Now we know what is an array. Array is a group of elements of similar data types, and we know that all in arrays, all the elements are stored in a sequence that is in the index. The index starts from 0, 1, so on. So here the elements are stored in a sequential order. Now a pointer top, this is the pointer top, contains the location of the top element of a stack, or it is top element of an array. The variable maximum stack, it contains the maximum number of elements that can be stored in the stack, or we can say the size of the stack. In other words, we can say it indicates the size of the stack or number of elements stored in the stack. And the condition top equals to max stock means the top of the element is equal to last maximum element. It indicates that stack is full, and top equal to null indicates the stack is empty. Now here we are learning few pointer or few definitions. One is we know that top is a pointer where insertion deletion takes place in stack, and another variable max stock, it indicates the size of the stack. And again, here whenever the condition top equals to max stock means when the last element the maximum element it reaches the last element of a stack, then indicates that the stack is full, so that when the stack is full we cannot insert any new element into the stack. Suppose top equals to null means if the top value is a null or -1, it indicates that stack is empty. See, these are all different terms we are using with respect to stack. Now this is how we represent the stack or assume in the computer memory. So first of all, you assume that this is an empty stack where there are no elements, and when you insert one element to it, so this is the first element. The second element will be inserted here. So this is an example of a stack where we are storing the elements in one over another in this example, or one after another horizontally, either in a row wise or column wise. So look at this. Suppose this is an array. The array index is 0, 1, 2, 3 and so on. And suppose this is the first position, and we know that top is the pointer where insertion and deletion takes place. So here, suppose top is here, so this is the last element inserted. Suppose if we want to insert one more element to it, so we have to push this top to this point, so then indicates that here is the one we can insert new element, for example 3. So similarly, then after this, suppose if the top pointer is at that position, this position, then it indicates that this is the place to insert new element, so we can insert 4. So this is how we can say stack grows in this direction. So this is, or we are implementing stack through array. This is the index 0, 1, 2, 3, 4. It goes on like this. So this is how we represent stack in computer memory. This is also another method of this. So if you assume that here at the beginning stack is empty, there are no elements, so this is the index 0. At the index 0 we have one element. Now this is the top pointer. Next the top pointer comes here. So at the beginning top pointer comes here. So when the top pointer is here, this is the place we can insert one element. Now once the top pointer moves from this to this point, then it indicates that this is the place this is the location we can insert new element into stack. So this is how the stack grows. Next one is operations on stack. Stack is a data structure and we can have different types of operations. So they are, first one is stack. So stack is an operator, or it is a function, it is an operation, it creates a new stack that is empty, means it is going to create a new stack. So this is stack. Next one is push an item. So here push item, it is a function, so it adds a new element at the top of the stack. Now we know that top is a pointer where we can insert new element into a stack. So push item, if we push is an operation to insert new element into a stack at the pointer top. Similarly, pop is a function or pop is an operation, so it removes the top item from the stack or removes the item at the pointer top. So this is for deletion and this is for insertion. Next one is peek, another operation peek. It returns the top item from the stack. So it is going to display or it output the last item of the stack and is empty. It checks whether the stack is empty or not. Next one is size. It returns the number of items on the stack. See, these are different operations can be performed on stack. In the next slide, we are learning an algorithm. This is an algorithm for push operation or how to insert element into a stack. So let us assume that stack is an array. It is a name of an array. So because we are implementing stack through arrays of containing n elements. So this is the size of an array, and we know that top is the point where we can insert new element into an array. And item, this is a variable, or the item, this is the item to be inserted at the position top. Now, if the algorithm, if top equals to n minus 1, now we know that n minus 1 is the last index of an array. So, if the top points to last index, that indicates that stack is full. So, we have to print stack is full, and we have to come out, we have to exit, because we cannot insert no more elements into the stack. Similarly, next, if condition fails, means if top equal to n minus 1, if condition fails, means the top is not the end point of an array. In that case, we have to increment the top, means top equal to top plus 1, means we have to push the top pointer to the new next element or the next index in an array, so that is the place we can insert new item into the stack. Accordingly, stack of top equal to item. So this is the way, this is a statement to insert an item at the index top. So this is an algorithm for push operation in stack. In the next slide, next one is pop operation. Another operation is pop operation. Here, pop operation, let us assume that stack is an array with n elements, and top is a pointer, the elements to be deleted. As we know, as we have learned now, the stack is a data structure where insertion and deletion takes place at the same pointer, that is top pointer. So accordingly, first we have to check for the top, where top equals to null. Whenever the top equals to null, it means that it is an empty stack. So once the stack is an empty, so there is no question of removing or deletion of any item from the existing stack. So once this condition is true, if it is an empty stack, we have to print stack is empty, then we have to come out of this algorithm. Next one is, suppose if it condition fails, means if stack is not empty, then we have to remove the element at the top pointer. So item equal to stack of top. So we are going to copy the element of at the top pointer to the item, the variable item. Next one is top equals to top minus 1. So here we have to decrement the top. As we have seen in the push operation, we have to push the top pointer to the next index or to the next sequence. But in pop operation, we have to decrement the top pointer, means we have to bring it to the previous index, so it means that the particular item or the data has been removed logically. So this is the pop operation of stack. Now let us see what are the different applications of stack. So simplest application is to reverse a word. To reverse a word, it is another application of a stack. Any words given to you, if you reverse it, then it is another operation or application of stack. Next one is, it is undo mechanism in editors. Now all of you know that whenever you work with computers or in editors, we know undo operation. So here undo operation means it's going to cancel the previous operation or previous action. That is another example application of stack. Next one is conversion of decimal number into binary. So conversion from decimal to binary, the operation requires her to keep on dividing the given number of decimal number by 2, and we have to store the remainder. And finally, we are going to keep the answer from the reverse order from the remainder side. That is another application of stack. Next one is another example, Tower of Hanai, and conversion from infix expression to prefix and postfix. See, these are all different applications of stack. Now in the next slide, we will talk about queue. Queue is another data structure. So here, what is the definition of this? It is an ordered collection of items where addition of new item and removal of the existing item always takes place at different ends. So this is a definition of queue, and in stack, removal and addition of or insertion of new element takes place at the same point called top pointer, but in queue it is a collection of elements where the insertion or adding new item or removal or deletion of an item takes place at two different points or two different ends. It is a collection of items where item is inserted at one end called the rear end. Here rear is a pointer, is a rear end where we are inserting the new data item, and the existing item is removed at the another end is called front pointer or front end. So there are two pointers here, front and rear pointer. Rear pointer is the one where we insert or adding new element into a queue, and front is the pointer where we can remove the element from the queue. So these are the two different pointers with respect to queue. So it is a queue is a data structure where the insertion and deletion takes place at two different pointers. They are rear and front. Now it is also called as FIFO list, or FIFO stands for first in, first out. Means the queue, it follows the principle of FIFO. Meaning here is the insertion are limited to one end and of the list called the rear end, whereas deletion are at the front end. So what is the meaning of FIFO? That is first in, first out. Normally in our day-to-day life, we know what is a queue. I mean, we are going to stand in a queue for different application, for different purpose. So whoever is going to stand in the queue first one, he is the one to come out of the queue, and that is the meaning of first in, first out. Whoever enters the queue and as the first person, he is the one to come out of the queue from the queue. That is an example for a queue. That is, students in a queue for fee payment, for example, people queue in a ticket counter. If you take the example of this, we can understand what is a queue. Here, the first element inserted will be deleted first. That is the meaning of FIFO principle. Now let us see what are all different types of queues. So here we can have following types of queue. One is simple queue, circular queue, priority queue, and day queue. These are all different types of queue data structure. Now let us see what is a simple queue. So this is how we represent queue in a computer memory. So here in a simple queue, insertion occurs at the rear end and the deletion occurs at the front end. This is the front end. So as we know that queue, it will be having, there are two pointers. One is front as well as rear pointer. So in this example, so this is a queue as we are implementing a queue in through arrays. So this is the array index. If it is an array 0, 1 to the index, last index is 8. So, and these are the elements of a queue. Here, rear is a pointer to insert an element into a queue, or it is a pointer where we are going to add new data item into a queue. Accordingly, rear at this point, the value of pointer rear is at the index 5. Suppose if you want to add one more element into it, so we have to push this rear pointer to this point where the index is 6. So here we can add, for example, one more data item into queue. So this is a place where we can insert new data item at the rear pointer. So now in this example, front equals to 1 and rear it was 5. Now if we want to add one more element to it, we are moving the rear pointer to 6, the index 6 or next index, the value of rear equals to 6. Now that is how the queue grows here. And again, if you talk about front pointer, so front is the pointer where the elements are deleted. So accordingly, in this example, at the pointer front equals to 1, so this is the first element to be removed from the queue, means first in, first out. If you observe this, we have inserted the element A first, B, C, D, E and F. So if you want to delete any elements, have to delete the element inserted at the beginning or as the first element. So this is the concept of FI, FO. Accordingly, front is the pointer. If you want to remove the element from this, so we have to move this front pointer like this, so if the pointer is at Q, it means that the element A is removed logically from the queue. So this is the one type of queue, or this is how we assume the queue in computer memory. So this is one type of queue, that is simple queue. Next one is circular queue. What is a circular queue? It is a queue in which all the nodes are treated as a circular in such that the last node follows the first node. So here, suppose at the beginning, this is the rear where we are inserting the new element, and as we keep on adding element, suppose this is the last index, the last element, that is index 8. So here this last index points to first index, to the 0. So this is the definition of circular queue, where the last node follows the first node in the form of a circle. So this is a circular queue. In priority queue, see, let us assume that this is the array and this is the queue, and here, and based on some priority, so the elements can be removed from any position at any point of time. That is the definition of priority queue. Next, let us see what are all different operations on queues. So here first is the function queue is going to create a new queue, that is empty. So new queue is an operation, it's going to create an empty queue. Next one is enqueue and item. So here enqueue and item, it adds a new item at the rear of the queue. Means if you want to insert a new data item into a queue, it has to be done at the rear pointer or the rear end. So this is enqueue of item. It is going to add new element into a queue. And similarly, dequeue. What is dequeue? It is removes the data item from the existing queue and at the pointer front. So front is the pointer where the elements are deleted from the queue. So it is an operation, it's going to remove the data item at the pointer front. Next one is empty. Is empty is a function or operation. It checks whether the queue is empty or not. Next one is size. It returns the number of items in the queue. Means it returns the size of the queue. So these are different operations on queue. Now let us see the memory representation of a queue. See, this is how we generally represent the queue in computer memory. And here, suppose this is the front pointer, rear pointer, and in this example, front equal to 1, rear equal to 4. So this is the place where you're inserting new element. Now, if you want to insert one more element to it, as I have told you in our previous slide, we have to push the rear pointer from 4 to index 5. This is the new element inserted. So this is how we represent the queue in computer memory. So accordingly, the value is going to change, the rear pointer value. In this example, rear, the value is 4 here, and here as we inserted new data item into a queue, the rear pointer moves from 4 to 5, index 4 to 5. Accordingly, the rear value is 5. So, and this is how we represent queue in computer memory. In the next slide, we will see representation of queue, and it is with respect to deletion of item from the queue. So here, as we have seen, if we want to insert it, we are going to increment the pointer, rear pointer by +1. Suppose if you want in deletion, so if you want to delete an element from the queue, for example, deletion takes place at the pointer front. So at this stage, the pointer index is 1, the element is A. So this is the first element to be deleted from the queue. If you want to delete this element, so we are increment the front pointer to this point. So here the front value, it becomes 2. In that case, it assume that next element to be removed is B. So whenever the pointer is at this example 1 means element A will be deleted first. Now when you increment the pointer, front pointer by 1 out to the next index, so this is the data element at this index to be removed next. So this is how the deletion takes place in the data structure queue. Now let us see the algorithm for insertion in a queue. Here let us assume that stack here Q be an array, linear array, and we know that front is the pointer for deletion and rear is the pointer for insertion. Now in the step 1, first I will check for rear is equal to n-1. So rear equal to n-1 in the sense n-1 is the last index of an array. So if the rear pointer reaches the last index, it means that the queue is full or overflow. Then it is not possible for us to insert any new data item into a queue. So we have to exit this operation. So if not, then if front equals to null. So what is the meaning of front equal to null? So front is the pointer where the elements to be removed. So if front is and null, that is equal to null, then front equal to 0 and rear equals to 0. That is an empty. Next one is else rear equals to rear plus 1. So if you want to insert new data item, we have to increment the rear pointer by +1. So it moves to the rear pointer, moves to the next index in an array. It indicates that is the place where we can insert new data item into queue. So this is an algorithm for insertion operation. Next one is, it is an operation for pop operation for deletion of an element. And here first we have to check for if front equals to null. If I say front equals to null, it is nothing but an empty stack. So front is a pointer and null is 0. If no elements are there, if the front pointer points to null, it means that it is an underflow or is an empty. Once if it is an empty, there is no question of removing any data item from the existing queue. So if front equals to rear, then here front equal to null and rear equals to null, else front equals to front plus 1. So here in deletion operation in a queue, we have to increment the front pointer by +1. It means that we are deleting data item at the front pointer. So this is an algorithm for deletion of an item from the existing queue. Now let us see what are different applications of a queue. One is simulation. Next one is various features of operating system, and it may include the process of execute or waiting for particular event to occur. And very simple example is your printer server routine. So if there are one printer with number of system connected to it, and any printing operations, any command or function given by different computers, all will be in a queue. So whichever the computer or the signal goes to the printer first, that will be executed. That is an example for queue operation. Similarly, multi-programming platform as well as application software is also based on queue data structure. These are all different applications of queue. Students, so far in this session, we have discussed about stacks and queue data structure. Now let us continue our discussion in my next session. Thank you very much.